Okay, so working with dilations. Now we've talked about transformations. We've talked about slides or translations that just move, right? Translations, so translate from just a slide left or up and down. That's like a translation. Talked about rotation, right, where it rotates or pivots around a point, right? It's rotated. And now we're talking about enlargements and reductions. So we're talking about actual dilations, they're called. So working with dilations. A dilations is a transformation that enlarges or reduces a shape or an object. You need to know the scale factor, and you should remember this from Workplace 20. We talked about scale factor. The number by which the side lengths are multiplied in order to draw the dilation. So it's the number by which all the lengths or a length in the shape is multiplied by to get the corresponding length in the dilation. So if you have a scale factor that's greater than 1, okay, greater than 1, that's an enlargement. So you might want to just highlight some of this stuff. A scale factor that's greater than 1 is an enlargement. A scale factor less than 1 will be a reduction. So that's pretty straightforward, right? Like if you have a scale factor of 2, everything is multiplied by 2 to get bigger. Okay. Although dilation is commonly used term to mean making bigger, in math it can also mean making smaller. So, just to review, on the side over here we have scale factor is a number by which all dimensions of an original figure are multiplied to produce the enlargement or the reduction. And similar figures, so once we've dilated something, once we've made it either larger or smaller, it's got the exact same shape but just a different size. And so these two figures then would be similar figures. They're the same shape and same corresponding angles as well. The corresponding angles are congruent. And their sides are proportional. So that means that they are all the corresponding sides are multiplied by the same scale factor. So a quick example here, and we'll have examples on both pages, but let's say we have some kind of strange that's a pentagon there. It's maybe not that strange, but so what I'm going to do is I'm going to copy this and I'm going to paste it right here. Now watch what happens if I were to enlarge it. See, it's the same shape. It's the same shape, but it's a different size, right? So if I was to measure this side right here, okay? If I was to measure this side, the corresponding side would be this one. So it's this times the scale factor would be equal to this new length here. Okay? So the original times the scale factor. Does that make sense? You guys okay with that? So if I took this shape then and I made it really big, then the scale factor could be 3-4 times as big, right? So let's take a look at that. And let's say we measure this and this is let's say this is 2.3, and so let's say this one is, say this is 6.1. So what is the scale factor between these two? What's the scale factor?
You want it in fraction?
No, in decimals, fine.
0.37.
0.37, you say. Okay, so how did you do that?
Well, we know that scale factor is scale over original. So we just do scale. It's 2.3 divided by.
All right, so here's the thing, guys. If this is the original right here, guys, this is the original, this smaller one, okay, this bigger one is the dilation, or it's the enlargement. Now, the enlargement, if it gets bigger, it has to have a scale factor that is greater than 1, so it's not this one. Now let's think about it. 2.3 times the scale factor has to equal 6.1. So in order to find the scale factor, we take the enlargement or the dilation length there and divide it by the original. So what's that number? 2.652. Okay, so that looks better. So this every side length would be multiplied by 2.652 to get the larger corresponding side length. Does that make sense? So the scale factor, if it's getting bigger, remember we just said, if it's getting bigger, then it's going to be greater than 1. Scale factor is greater than 1 when it's an enlargement. Okay. So let's take a look at this example here. So it gives you a figure, and it says dilate this rectangle by a factor of 2, scale factor of 2. What are the side lengths? So if everything is multiplied by 2, then this length right here, which is 2 units, this one has to be what? 4 units, right? So I'm going to draw it right here, I guess. So it has to be 4 units. This one is 1, 2, 3, 4 units, so it has to be 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So there is your enlargement. Scale factor, and you should make your lines a little straighter than mine. But that's times 2, right? So times the scale factor of 2. If we're going to make this dilation by a scale factor of 0.5, that means that the new one has to have all of the dimensions have to be half. So it would be 1 by 2 instead of, so this is 2 by 4. This one is, 4 by 8. And this one, the half, is going to be 1 by 2. Okay? Makes sense? This should be, hopefully, refreshing your memory from before. Okay? So yeah, so there's the original in dark. There's the larger one is double. Well, all the sides are double. And the reduction has all the sides multiplied by 1/2. Okay, so let's take a look at this Build Your Skills question number 1. And let's do this one together so we can get started on these questions here. So it says a scalene triangle has side lengths 5.2, 6.4, and 9.6. What will the side lengths be if it undergoes a dilation by each of the following scale factors? Okay, you don't have to draw the triangle. You don't really have to, but you can, I guess. So 5.2 is going to undergo an enlargement because the scale factor is greater than 1. So we're going to multiply that by 7, and that side length is going to be 5.2 times 7. And that one's going to be 36.4 centimeters. And we multiply all of the other sides by 7 as well. Times 7, and you should get 44.8 for another side, and finally one more. 6. So each side gets multiplied by the scale factor. Okay? So 5.2 becomes 36.4. 6.4 becomes 44.8. And 9.6 becomes 67.2. Okay? So those are the new side lengths. Any questions there? Multiply by the scale factor. And you would do the same here for 0.4. So 5.2 times 0.4. And 6.4 times 0.4. And 9.6 times 0.4. Okay, so you can go ahead and finish that first question there. Right, so there should be the numbers for 16b. All right, let's take a look at 17 together because this one is going to take a little bit of thinking. Okay, it's a little bit different. So it says Rob took a digital photograph that is 9 inches by 15. Now, if you want to draw a sketch, you can 9 by 15. Just a rough sketch that is roughly proportional. You can. So here's the picture, right? A little less than, well, that actually might be a little bit long there maybe, but anyways, it's a rectangle, right? So here's 9, so 15 is 9 plus another 6, so let's say it's maybe about like that. Okay. So that's roughly proportional. Now, it says he has one picture frame that's 5 by 8. Oh, okay. So 5 by 8. Okay, so it's a little bit smaller. And one that is 8 by 10. So 8 by 10. Now, these pictures that we're drawing are not going to help us answer this question. We have to kind of get down to some math here. But what we have to do is we have to figure out, can the photograph be dilated, that is reduced, okay, because both these are smaller, to fit the frame. So that means, would they have the same shape? Okay. So there's a couple different ways you could do this, and I don't know how you would want to do this, but you'd want to check I guess to see if, this is one way you could do it. You could say 9 over 15. Is that equal to 5 over 8? Because if they have the same ratio, one to the other, then they can be enlarged or reduced. Okay, so we could check that. We could check the scale factor. Okay, so that's one way you could check that. Here's another way. You could check the scale factor between two corresponding sides. So 9 to 5. So if we did 5 divided by 9, that would give us the scale factor. And if we did 8 divided by 15, that should also give us the exact same scale factor. So we could compare to see if the scale factors between the corresponding measurements are the same. So let's get on our calculator. We'll do both of those together. So let's see, 9, turn it on, clear it. 9 divided by 15 is 0.6. 5 divided by 8 is, 0.625, not quite the same. So it looks like that maybe this might not be the same shape. So let's try 5 divided by 9. Okay, so here the scale factor between the first two, I'm looking at these two right now, the scale factor between the 9 and 5 is going to be 0.5555. Now let's check 8 over 15 and see if it's the same. 8 divided by 15. Not quite the same. So do you see how this is not the same proportion? It's not the same ratio, the sides. So we don't have the same scale factor. So it looks like this picture cannot just be reduced to have the exact same shape as this one. Okay? So the 5 by 8 inches, no. Okay? No. Now, we could check as well this 8 by 10. And we could do one of the same ways. We could do the same thing. So let's check the scale factor. Okay? Let's check the scale factor here. And this is 8. So 8 over 9 should give us the scale factor. It's 8/9 of this original one. And then 10 over 15. So we could compare those two and see if those scale factors for the corresponding sides are the same. So this is 0.88888. And 10 divided by 15 is, not the same. So it looks like this one here too, the 8 by 10, that's a no-go either. So you would kind of pick one way and just check to see if they're the same shape and if they're a reduction of the original. And so you would say no for A. Any questions about that? Okay. So again, you want to use scale factor and know that scale factor has got to be the same for all of the corresponding sides of the similar shape. So the 9 and the 5 have to have the same scale factor as the 15 and the 8. In this case, it does not. So B, let's take a look at B. Rob wants to make a poster of the photograph by dilating it by a factor of 3. What will the dimensions of the poster be in feet and inches? Okay. So here's our original again. It's 9 inches by 15 inches. So I'm going to take 9 inches and multiply by 3. That's going to be 27 inches. And I'm going to take the 15 inches and multiply by 3, and that's going to be 45 inches. So these are the new dimensions, and it says what will they be in feet and inches. So do you remember how to do this? There's 12 inches in every foot, right? So what does this one turn into be? 27 inches. Well, that is 12 plus 12 is 24 plus 3. You see that? So that's going to be 2 feet, 3 inches. Does that make sense? Do you remember doing this stuff? You could just divide it by 12, but then you're going to get a decimal. And so, well, is a decimal bad? Well, watch this. 27 divided by 12, watch this. You get 2.25. So that's 2 full feet. But then it's 0.25 of a foot. This is not 0.25 inches. So you can think of it this way, but then you have to think, okay, well, what is 0.25 of a foot times 12? That is, 3. So it's 2 full feet and 3 full inches. So you could do it that way. You just got to be careful with that decimal, yeah. Okay? Okay, why don't you guys try this, 45 inches. How many full feet and how many leftover inches would that be? All right, so if you've had a chance to do this, 45 inches, okay, you can do it this way, where I just kind of kept adding 12 inches until I got something just underneath 45, which this would be 36 inches right here. And you know that that's 3 full feet, and then there's 9 left over. The calculator way would be taking 45, dividing by 12, you get 3 whole units, that's 3 whole feet, and then 0.75 of a foot. Multiply 0.75 times 12 inches, you get 9 inches. Okay, you can do it that way as well. So that's how you get 3 foot 9 inches. Okay. Good, you guys good? All right, so let's see, there's a question there. So we are kind of at the end of 6.1 part 2, and I think you have the practice your skills questions. So what I'm going to ask you to do is finish the build your skills questions, and then start the practice your new skills questions and work for the rest of the period on that. Got lots of time. Do these questions here, and then you should be able to get done 6.1.
We'll have 2 of those 5 quick.